All right, so we have some warm-up problems today. Some chain rule, derivatives, some antiderivatives or integration for number 1, a limit to infinity for number 3, and then we're going to find some critical points of what I would call a composite, well, it's a polynomial, but I'm going to do that as a product rule derivative for number 4. So start with number 1. First thing I would do is get everything in the numerator. When you have 1 over the third root of x squared, bring it up and write it as a negative exponent, because it's much easier to integrate using our rules if everything's in the top. So the first thing I see is that this is f prime of x.
We make it negative x to 2/3.
Negative 2/3. X to the negative 2/3, yep. Minus 4x to the 7th. Then our rule is simple. And I'm not going to simplify this indefinite integral. I'm going to find the original function. We know it has a plus c on the end. Do we all agree? Plus c for calculus. All right, so I know the order's got to go up 1. So negative 2/3 plus 1 is 1/3. And we divide by the new power, which is 1/3. I lied. We're going to have to simplify it one step. Minus, again, add 1 to 7, I get 8, and divide by the 8.
Once it's really negative.
Nope, because when you add 1 to negative 2/3, you get a positive third. Negative 2/3 plus 1. Because we're antiderivatives. We're going up.
Okay.
We're adding 1.
Right.
You get that?
Get that. Well, why wouldn't it be negative? Because you're
Negative 2/3 plus 1 is 1/3. Plus 3 over 3.
Taking a simple algebra here.
Negative 2/3 plus 3 over 3.
Oh, okay.
1/3. And the function we would have to write, because we don't leave a fraction hanging out, would be 3x to the 3rd minus 1/2 x to the 8th plus c. We check the derivative of that last statement and make sure it is that, and it is. So we are golden.
We are in different
Room. All right, so we're going to pause the video and try to have Albany join us. All right, we got Albany on, and now we're going to finish the warm-up. I got the next one, number 2 here, is the derivative of sine cubed of the argument cosine 3x squared. So the argument of sine is the cosine function inside. So we're going to have to do a chain rule, all right? And I'm not going to simplify it. I'm just going to take my time and do it here. We look at this, and the 3 comes down. Do we all agree? And the sign doesn't change, and the argument doesn't change inside. All right? And then we took sine cubed. So what's the derivative of sine? Cosine. And the argument inside is still cosine, guys. So it's cosine of cosine 3x squared. Now I look inside, all right? I'm going to have a little more space here. I'm going to change it to so now I look inside at the cosine 3x squared. And we say, what's the derivative of cosine 3x squared? Yep, the negative sine the 3x squared, that argument. And then finally, we look at 3x squared. What's the derivative of 3x squared? 6x. Holy cow, we're getting more and more links. You guys see it? Every day we're getting a little better at this. All right? And that is the derivative. I'm not going to simplify it. I would just take 3 times 6x, though. And there's nothing else I could really simplify with this. All right? 3 is negative 1/3. It is that easy. I agree. It's a lick. Because I'm going to go through the proof of it, though, okay, today. 3 is negative 1/3. And we should practice this to the point where we just see it. It is 4 over negative 12 because those are the highest orders. All right? And when we got it, I think what we all agreed is the answer to this is negative 4/12, which is negative 1/3. All right? The reason this works, all right, before we do number 4, finding some critical points as our warm-up today, okay, is we have to realize that in our head we're doing a rule here in green. that anytime we have a limit as x approaches infinity of a reciprocal type function, 1 over x to the n, where n is some number greater than 1, this goes to 0. And the proof of this, to prove it's negative 1/3, is that we look at these statements. All right? We look at these statements and we say, hey, I can multiply the top of that limit by 1 over x cubed and the bottom of this limit by 1 over x cubed. That's the highest order in the problem. Do we all agree? So when I do that, I get the limit as x goes to infinity. When I distribute 1 over x cubed, I get 4 minus 9 over x plus 7 over x squared over negative 12 plus 4 over x. You guys agree? Guys, I just made a rule here that we got to know. And remember, limit rules say I can go into all these 5 terms, right, individually. So what is the limit as x approaches infinity of negative 9 over x? 0. What's the limit as x approaches infinity of 7 over x squared? 0. The proof of this is here. Now, usually what I have with calc students is a whole bunch of people going, Anderson, you're killing me. I just look for the same order. But you notice on the last test, I had x cubed in the top and the square root of x6 in the bottom, which is the same order, but you have to distribute it in to see it then. All right, so the answer to this one is negative 1/3. Last warm-up today. Guys, do not cube out x plus 2. Do not multiply out x plus 2. Find the critical points of the function y equals x times x plus 2 quantity cubed. That's where y prime equals 0. So believe it or not, you want to get used to writing this, guys. Critical points happen there. If you're taking the AP, that's worth a point a lot of times. Now I have to find the derivative, right? F times g. You guys see it? F times g. I'm going to make fx and g x plus 2 quantity cubed. So the derivative of x is 1 times x plus 2 cubed plus x times the derivative of x plus 2 cubed is 3 x plus 2 quantity squared times inside of that is 1. Do you guys agree? All right, so we know we took the derivative of x plus 2. All right. Now, like your homework, this is one you're going to have to factor. So I end up with x plus 2. I do a little step here so I kind of start to see it come together. And I don't multiply out. I don't multiply out. I don't multiply out. We always factor. So I look at my 2-term derivative and what's common? X plus 2 quantity squared, right on. X plus 2 quantity squared. That leaves an x plus 2 and a 3x. Well, that I can simplify because, so I get y prime equals x plus 2 squared, and I think this becomes 4x plus 2. I think my zeros then, I have a repeat here, a multiplicity, right? I think y prime equals 0 at negative 2, and it looks to me like negative half. And I just found the x value critical points. Now, because, do we all agree, x times x plus 2 quantity cubed is probably a polynomial? It is, not probably. It is a polynomial. These are almost for sure maxes and mins. Okay? I'm not positive without doing the first derivative rule, but it would most certainly be that. If we want to do sketching now, we would use these two values, and then we take the derivative again. Everybody, I'm not going to do that today. All right? I'm not going to do that today.